going to talk about sum and difference formulas next. And I just want to do a quick exercise to kind of prove to you why we need these formulas. The question we're asking ourselves is the sine of angle A plus B equal to the sine of angle A plus the sine of angle B? So let's just try it. I mean, we can't prove it for all things by just using an example, but let's pick an example. So let's say we made A 50 degrees and B 20 degrees. Just randomly picked a couple of things. So we're going to first use our calculator to compute the sine of A plus B. That means we're going to add A plus B together, and then we'll find the sine of that. So that would be the sine of 70 degrees. Make sure I'm in degree mode. Find the sine of 70, and I get 0.9397-ish, rounding it to the nearest fourth decimal place. So now I'm going to try the other side. I'm going to do the sine of angle A, so sine of 50 degrees, plus the sine of angle B, so the sine of 20 degrees. So I'm going to find the sine of each one and then individually, and then add them together. And now I have 1.1081, again, rounding. So clearly the answer is no. It is not true that the sine of A plus B equals sine of A plus sine of B. So we end up with some formulas on the next page. We have a whole set of these identities that tell us how to do the cosine, the sine, and the tangent of two angles added together. Now, to be honest, we do not use these nearly as often as the other identities that we've just discussed in the last video and some that are coming up in the next video. So mostly you need to be aware that these exist, that you cannot just do cosine alpha plus cosine beta. You have to use a formula, but you do not need to memorize these formulas. Okay, so what I'm going to do is I'm going to just go through some examples of using them. And one of the reasons that it's kind of nice to use these is it does make you practice your finding values of trig functions. That's kind of the best reason that I include them in this lesson. So for example, the first question says find the exact value. That means don't just plug it into your calculator and get a decimal. Find exactly what this cosine of this sum equals. So I have a cosine of A plus B. Cosine of A plus B, alpha, beta, just call it A plus B if you want. So I have to use this formula right here. Okay. So I'm going to write that down. If this is my A and my B, or my alpha and my beta, I'm going to do cosine of the first one times cosine of the second one minus sine of the first one times sine of the second one. So I'm just applying this formula to this particular example. And now all it really becomes is a process of filling in these values. And you can find these values from your special triangles, right? So at this point, you have either kind of memorized the triangle values and you can do it in your head, or you just draw it. It doesn't matter. Oopsies. 30 degrees would be pi over 6. That's where the root 3 is. And then the 45. Pi over 4. So cosine of pi over 6, cosine would be adjacent over hypotenuse. Cosine of pi over 4 would be 1 over root 2, or root 2 over 2. Oh, not equals. One too many horizontal lines there. Sine of pi over 6 would be opposite over hypotenuse. And sine of pi over 4 is the same as the cosine. So then I'm just going to multiply those two, multiply these two. Oh, they already have a common denominator. So I could write it like this. And that is the exact value. I didn't rationalize it. If I was going to rationalize it, probably would have just written these as root 2 over 2. That would have made it rationalized in the end. Okay. Or we could have a similar type of problem like this, but we just have to do a little bit more work. Given that cosine A equals a certain number and A is in quadrant 2, sine of B is a certain number and B is in quadrant 2. Find cosine of A plus B. Oh, look at that. It's the same formula. Lovely. So cosine of A plus B, I'm just going to copy back down the formula. It's cosine of A times cosine of B minus sine of A times sine of B. So those are the 4 pieces of information I need in order to answer this question. Well, good news. I know cosine of A. It was given to me. And I know sine of B. It was also given to me. So I'm going to go ahead and write in my cosine of A. I don't know what my cosine of B is yet. I don't know what my sine of B is yet, but I know my sine of A. I don't know what my sine of A is, but I do know my sine of B is 7 over 25. So I'm basically halfway there. I've got 2 of the 4 things I need, but now I need to find cosine B and sine of A. So let's start with cosine of B. I'm going to come over here to the information they gave me about B. Since they gave me a sine and a quadrant, this would be my reference angle. And I can fill in the sine would be opposite. Oh, that's not the second quadrant. Try again. Second quadrant. There's my reference angle. And they gave me the sine, which would be opposite over hypotenuse. So now we just need to find this missing side, and we can fill in its cosine. So use your Pythagorean theorem. 25 squared minus 7 squared. Whoops. And square root that would be 24. So I filled in this side using my Pythagorean theorem, and I need the cosine of this angle, which would be negative, second quadrant, 24 over 25. Okay, now we need to find the sine of A, so we're going to use the information about angle A, also in the second quadrant. Cosine is 5 over 13. So a quick Pythagorean theorem tells me that this side is 12. And so the sine in the second quadrant would be positive 12 over 13. And now it's just a matter of multiplying those things together. 5 times 24 gives me 120 over 325 minus 84 over 325, which is 36 over 325. So now I have my exact value of the cosine of A plus B.